الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم إدارة لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول درس جديد في مادة الجبر، هو بعنوان الصورة المركبة للعدد المركب، الصورة المثلثية للعدد المركب trigonometry form of complex number. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in algebra. It's called trigonometry form of complex number. My dear student, look at polar and Cartesian coordinates. The opposite figure represents a circle with radius, length r, and the point A, x, y lies on the circle, and opposite to angle of measure angle theta. My dear student, look at, we have circle. Radius is r, and the point x, y lie on the circle. Opposite angle theta, angle inclination r with x-axis. Cosine theta equals what? X over r. Sin theta we know y over r. Then we deduce that x equal r cosine theta by using cross multiplication, and y r sin theta. In the polar form, we were studied the polar form in the previous. We can put x as r cosine theta and y r sin theta. R equals square root x square plus y square and tan theta y over x. Theta equals shift to n y over x by using calculator. R is called modulus and theta is called amplitude. If we meditate the Cartesian plane as a polar plane where the polar axis coincides on the positive part of x-axis, convert polar coordinates to Cartesian coordinates. If the point in polar coordinates A are theta, then Cartesian coordinate of point A is r theta, where x equals r cosine theta, y r sin theta, then xy represent r cosine theta plus r sin theta. We take r common factor, r cosine theta plus sin theta. I. Operations on the set of complex number. As the first, if we have z1 x1 plus i1, z2 x2 plus I y2. When z1 equals z2, what you deduce? Real equal real, imagine equal imagine. x1 equal x2, real equal real, imagine equal imagine, y1 equal y2. If we have x equal x plus 3i equals 4 minus yi. X equal what? 4. Real is real. Y equal negative 3. Imagine is imagine. Z1 plus Z2, we add real with real and imagine is with imagine. Example, Z1 3 plus 2i, Z2 3 plus I, Z1 plus Z2 equal what? 3 plus 3, real with real, 2 plus 1, 3i. Then Z1 plus Z2, 6 plus 3i. When we multiply Z1, Z2, complex with complex, we have more method. First times first, second times second, mean times mean, extreme times extreme, or we expand x1 multiply the second bracket plus y1 multiply the second bracket and add the like terms. In this example, Z1 5 plus 2i, z2 3 plus 4i. What is z1, z2? z1, z2, we multiply 5 times 3, 15, 2 times 4, 2i times 2, 4i, 8i power 2, negative 8, and mean with mean, and extreme with extreme. 5 times 4, 20i, 3 times 2i, 6i, therefore we add like terms, 7 plus 26i. z1, z2, 7 plus 26i. Conjugate of the complex number z is z bar. If we have z equal x plus yi, therefore conjugate of that or x z bar x minus yi. Now we are taking properties of conjugate values. z1 plus z2 bar is a real number. z1 plus z1 bar is a real. Why? Look at example z 3 minus 4i. Z bar 3 plus 4i. When we add z plus z bar, 3 plus 3, 6. Only this real. Z plus z bar equals 6 is real. Belongs to R. Z1 dot z1 bar is a real. Also, z equals 2 plus I. What is the conjugate? 2 minus I. Remember, conjugate, change the sign of imagine. Z times z bar, 2 plus I inside bracket times 2 minus I inside bracket equal 4 minus I square. 4 positive 1. Why? Because I square negative 1 equals 5. I square equals negative 1. Negative, negative, positive 1. 4 plus 1 equals 5. Also, conjugate of z1 plus z2 equals conjugate of the first plus conjugate of the second. This is important. Conjugate. Conjugate of addition equal addition of two conjugate. z1 2 plus 3i, z2 1 minus I, z1 plus z2, we add real with real, imagine with imagine. 2 plus 1, 3. 3i minus I, 2i. z1 plus z2. What is the conjugate of z1 plus z2? 3 minus 2i. Since z1 equals conjugate of z1 equal 2 minus 3i, conjugate of z2 1 plus I, therefore conjugate of z1 plus conjugate of z2 equal 3 minus 2i, then we deduce that conjugate of add equal add of conjugate. Conjugate of addition of two complex number equal addition of two conjugate of two complex number. Therefore, we deduce that conjugate z1 plus z2 equal conjugate of the first plus conjugate of the second. Conjugate of times z1 times z2 also equal conjugate of z1 times conjugate of z2. Example, z1 equals 1 plus I, z2 3 plus 2i. What is the multiply? z1, z2, 1 plus I, multiply 3 plus 2i, first times first, second times second, mean times mean, extreme times extreme. Answer is, after like terms, 1 plus 5i. What is the conjugate of multiply? z1, z2 conjugate equals 1 minus 5i. This is number 1. Conjugate of the first 1 minus 5i. Conjugate of the first z1 1 minus I. Conjugate of the second 3 minus 2i. z1 conjugate of z1 multiply conjugate of z2. 1 minus I multiply 3 minus 2i. Answer is by using like terms 1 minus 5i. What did you deduce? Yes. From 1 and 2 we get conjugate of z1 dot z2 equals conjugate of the first times conjugate of the second. If we have z1 equals z2, therefore we deduce that conjugate of the first equal conjugate of the second. If z equals z1 z2, conjugate of z equal conjugate of z1 times conjugate of z2. Also, if we have z complex number equals z1 over z2, conjugate of z equal conjugate of the z1 over conjugate of z2. Look at I. How to simplify? I power 20 plus I power 25 plus I power 30 plus I power 35. Choose the correct answer. Maybe 1, negative 1, I, negative I. I power 20. We know that I equals square root negative 1. I power 2 equals what? I power 2 negative 1. I power 3 negative I. I power 4 equals 1. Then, my dear student, I gave you summary to calculate I without calculator. If the power is even, as 20, I power 20. If the power divisible by 4, answer is 1. Then I power 20 is 1. If the power not even not divisible by 4 equal negative 1. Is right? Again, if the power is even divisible or divisible by 4, answer is 1. Power even not divisible by 4 equals negative 1. Then we deduce the power even included between 1 and negative 1 equals 1 when divisible by 4 equals negative 1 not divisible by 4. If we had power odd as 25, is the power 25 divisible by 3 equal negative I, but not divisible by 3 equals I power 30. Even or odd? Even. Divisible by 4? No. Therefore, negative 1. I power 35. Odd or even? Odd. Divisible by 3? No. Answer is I. This right? Look at solution. 1. I power 20 is 1 because divisible by 4. I power 25 equals I, not divisible by 3. I power 30 equal negative 1. Why? Not divisible by 4. Even. 35 equals negative I. Therefore, answer is 0. 1 over I equals what? I power negative 1. 3 over I power 3 equals 3 I power negative 3 or negative 3I. 5 over I power 5 equals what? equals 5i power 3 or negative 5i. 7 over I power 7 equals 7i. Why? I power 7. 1 over I power 7 equals I power negative I power 1, because 7 I power 8. I power 8 equals 1 over I power 7 equals 7i. The first, I power negative 1, 3i power negative 3, 5i power negative 5, 7i power negative 7. I power negative 1 is I power 3. I power negative 3 is I. I power negative 5, I power 8. 7, I power negative 7, 7i. I power 3, negative I, plus 3i, negative 5i, plus 7i, like terms, 7i plus 3i, 10i, minus 6i, equal 4i. Expand 2 plus I for all power 4. As a first, expand 2 power I for all power 2 for all power 2. Answer is 3 minus 4i for all power 2. First power 2, 9. Second power 2, 16. I power 2, negative 16. First times second times 2, negative 12 times 2, negative 24i. Then 9 plus 16 I power 2. 16 I power 2, negative 16. 9 negative 16 equals negative 7. Final answer, negative 24i. Find in the form a plus bi if z equals 3 minus 7i over 5 minus 2i by using calculator, or multiply by conjugate of 5 minus 2i up and down. Z equals the fraction 29 minus 29i over 29, or 29 over 29 minus 29 over 29i equals 1 minus i. Z equals 1 minus I. In algebraic form, a plus bi. This complex number in as algebraic form. If we have z equals 7 minus 2i over 2 minus I, find z bar. Z bar, we convert z by using conjugate of denominator. Z equals, in this case, 15 plus 5i over 5, take 5 highest common factor equals 3 plus I. But what is the conjugate? 3 minus I. Conjugate 3 minus I. Don't forget, if we add z plus z bar equals 6, equal real. Also, we multiply, if we multiply z bar, also real. Why? Number multiply conjugate must be belongs to R. Z times 3 times 3, 9. I times negative I squared, positive 1. 9 plus 1 equals 10. When we add or multiply number, complex number by conjugate, the answer is real number. If we have z 1 plus 4i plus 3i squared minus 7i power 3 over 4 plus 7i plus 3i squared plus 5i power 3. What is the value of z bar for all power 2? We know that 3i squared in numerator equal negative 3. Negative 7i power 3 equal positive 7i. Why? Because I power 3, negative I. Negative I times negative 7, positive 7i. Also 3i squared negative 3, 5i power 3 negative 5i. By using simplify, we reduce that. Z equals negative 2 plus 11i over 1 plus 2i by using calculator, or multiply by conjugate of denominator 1 minus 2i up and down. Multiply conjugate up and down, 1 minus 2i over 1 minus 2i. Therefore, Z became 20 plus 15i over 5, taking 5 common factor in numerator. Z equals 4 plus 3i. The required Z bar for all power 2. At the first, what is the Z bar or conjugate? 4 minus 3i. What is the power 2? We find square of the first, square of the second. First times second times 2. 4 power 2, 16. First times second times 2, negative 24i plus 9i squared. You know that I squared equal negative 1. Then 16 minus 9 equals 7 minus 24i. This Z bar for all power 2. Z bar for all power 2 equals 7 minus 24i. If we have 3 minus 2i plus 5 plus 3i equals 4 minus 3 minus 2i x, 5 plus 3i y equal 4 minus 9i. Find the value of x and y. X multiply 3, 3x, x multiply 2i, y multiply 5, y multiply 3i. By using like terms, 3x plus 5y equal 4, real is real. Therefore, x equals 4 minus 5y over 3. Also, negative 2x plus 3y equal negative 9. We use negative 2 multiply 4 minus 5y over 3. This value of x plus 3y equals 9, equals negative 9. Therefore, by using cross multiplication, find the value of y equal negative 1. By using x equal, by using substitution about y equal negative 1, and x equal 4 minus 5y over 3, answer is 3. Solve in complex number. Z power 2 plus 25 equals 0. We know that z power 2 plus 25 equals 0 in real is 5, but in complex number, z power 2 plus 25 equals 0, z power 2 equals negative 25. Therefore, positive or negative square root negative 25, positive or negative 5i. Why? Because square root negative 25 equal square root 25 times square root negative 1, and we know square root negative 1 equals I. Z equals positive or negative 5i. Solution set 5i, negative 5i. Another example, z squared plus 4z plus 13 equals 0. What is the value of z? We know by using general formula, a equals 1, b equals 4, c equals 13. Negative v, positive or negative square root b squared minus 4ac over 2a, by using substitution about a and about b and about c. Therefore, the value of z, negative 4 positive or negative square root negative 36 over 2. Therefore, by using square root negative 36 equals 6i, negative 4 positive or negative 6i over 2, taking 2 by using highest common factor, 2 divided 2 equals 1. Then answer is negative 2 positive or negative 3i. This is the value of z. Solve. What you mean? Solution set. Negative 2 plus 3i, negative 2 minus 3i. Children, By the end of the lesson, we know that complex number is very important lesson. And we have three forms of complex number: polar form, algebraic form, trigonometry form. After that, we are taking Euler form. My dear student, complex number z equals r multiply cosine theta x plus I sine theta x y. My dear student, in complex number we have r, its modulus of complex number equals square root x squared plus y squared. And the complex number has amplitude angle theta by using shift tan y over x. We can convert the complex number form from trigonometry into to algebraic form and vice versa, as x equals 1 plus I. X equals 1, y equals 1. After that, we find the r. Modulus r equals square root 1 power 2 plus 1 power 2 equals square root 2. Then find the angle theta, shift tan 1 equals 45. Then we can put the complex number r is root 2 multiply cosine 45 plus I sine 45. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.